The final concept of object-oriented programming that we're going to be discussing within this section is polymorphism. Now that sounds a little bit like a complicated term, but it really isn't. The concept behind polymorphism is really just the fact that we can have a single view of a particular object, but the underlying implementation can change depending on the class you're using. So let's look at a concrete example of this. So we have our base class here, our public class customer, that has some information behind it. So we have some properties, first name, last name, and email, and then we have a few methods here, one of them exposed publicly as a Boolean return type called save. Now this is going to have some sort of generic logic in here that's going to ultimately validate some code, do some database setup, and then return some response based on how the entire save process went. But we're really not specifying how it is we're saving, so there's something going on in here, but we don't really know what it is. So now let's say we're dealing with these two different types of customers. We have a retail customer and we have an online customer. So let's say that for the time being, we want to save our retail customers into a database somewhere or some other storage mechanism, and maybe we want to save our online customers into our new cloud storage solution or something like that. So ultimately we want this to seem like it's still our customer class, our experience to our end user, which is ultimately the main method up here in our program, in our program class. We want to still be able to call save, but once again, that whole encapsulation concept, we don't really care what it's doing or how it's doing it. We just want to call save and know that it's going to work properly. So let's go back to our example here. We have our retail customer and we want to be able to save it, but we don't want to use the functionality that's exposed through our base class here. So in order to change that, or to use this concept of polymorphism, we want to give a new instance, or basically override that existing implementation with our own. So the way that we do that is by saying, all right, I will have a public method now, and I want to create an override of an existing, and I want to override our method that returns a Boolean and is called save. Just like this. Now you can tell, and I'm using ReSharper here, and you can see that it's giving me some red squiggly lines because something isn't right, and there's no suitable method for override. But I know that I've created a save method within my base class here, so why does this not work? Well, the reason this doesn't work is because in order to support this overriding of functionality, the method within your base class that you are overriding must be marked as virtual. So virtual really just means that I am going to give you a very simple or a base implementation of this particular method, but you are allowed to override it later on in some other class that inherits from my base class by using the override keyword. So in here I can do some other sort of saving. So let's say in this case I want to save to a database, and then I'll return the result from that, and in this case it'll just be true. So that should work just fine for our retail customer. So now let's say though that our online customer, we want to save this in our new fancy cloud storage off somewhere, but we really don't want to change our footprint or what our interface looks like to the outside world or to our consumer, so we're going to do the same thing. So now in this case, we can copy this, and we'll put in here, this is going to save to some sort of cloud storage. Something along those lines. So now we have completely changed the implementation of our base class method of save by overriding that particular method in both of our new retail customer and online customer classes. So this is an example of polymorphism where we're not changing the outward appearance of our application or of our class in this case, but we are changing the implementation of that particular method. Now this obviously opens a lot of interesting scenarios where maybe I don't want to allow certain subclasses to override methods, or maybe I don't want someone to be able to just use this base implementation of a customer. So let's talk about a few of those different scenarios. So if we were to come into a situation where we're just creating this class as an opportunity to base other subclasses on. So let's say I don't ever want somebody within my application or somebody consuming my code to ever create an instance of this customer class. This is only meant for creating subclasses in this way so that we can differentiate between the two different types of customers, or however many different customers we have. Well, the way that we do that would be to decorate the public class statement here with the abstract keyword. So now this means that I am not allowed to ever create an instance of just this customer class in and of itself. So if I were to come up here, you'll see that I'm getting an error because I'm not allowed to create a new instance of an abstract class. So that kind of saves me from doing those types of things. So now I can say if I ever want to use this implementation or any of these features within my base class, my customer class, you have to do it through one of these subclasses. So that's the first part. And now you've also already seen, now if I want to override some of the functionality here, I can provide the consumer of my application to be able to do that by marking my methods as being virtual. So that means I'm going to provide a base implementation, but feel free to override it if you wish. Now there's another scenario that's somewhat similar to that where you can override it, but that it's going to be required to override. So let's say within my customer base class here, I create another method and it's not going to return anything, and we'll just call it do something. Just like this. Now, if I don't know how this do something method is going to work at the time when I'm creating my base class, so we're going to require that there's some sort of functionality that happens when a customer or when a consumer uses this do something method, but I don't specifically know what it is at the base class level. It's going to be very dependent upon these implementations of the subclasses. So in that case, I'm going to mark this method very similarly to how I did my class up here as being abstract. I'm going to mark this method as being abstract, but now I need to get rid of any semblance of an implementation, and I just place a semicolon at the very end here. So now I'm declaring the fact that there needs to be a do something method in all of these subclasses that inherit from customer, because I'm marking it with abstract. So if I were to come down here now, you're going to see I'm getting errors on these two creations or these declarations of an online and a retail customer because I haven't created an implementation of the do something method. So I can go ahead and add an implementation of that, and now you can see now I'm making everything happy here, as everything should compile just fine. Now the concept of virtual and abstract are not just specific to methods. I can also do the same thing here on first name. So if I had some sort of custom logic in my getter and setter that had to do with the first name, I could mark this as virtual and say that anybody that is inheriting from my customer class could ultimately override this as well. So it doesn't have to be just specific to these particular methods. And then finally, one of the examples that becomes quite interesting as well is, let's say I'm creating a class, base class here that's customer, that's an abstract class, and I want people to inherit from this and use this base functionality and override where it makes sense. So now we come down to a retail customer and an online customer. Now let's say I don't want people to be able to inherit from or subclass retail customer and online customer, simply for the fact that this is my logic and I don't want other people to be messing around with it. It's very crucial to this application. So if you want to do something else, then you're going to have to create your own classes and your own functionality, or maybe go back and inherit from this base class, this customer class on your own, but you have to leave my implementations alone. And the way that you do that at the declaration of your class level is by marking this as being sealed. So now if I have a sealed class that's a retail customer, I cannot come in here and create a new class. So let's say another sealed customer or another retail customer, and then have this inherit from retail customer. As you're going to see here that I can't do that because I cannot inherit from a sealed class. So this provides a level of protection of my code from anybody else not being able to inherit from it and ultimately override from it. So In this lesson, we've kind of gone through the process of what polymorphism is, as well as some of the other aspects of being able to inherit from base classes and override certain things, making it optional to override or required to override, or stopping people from being able to inherit from and override my implementation of a particular type of customer. Now that we have the concepts of object-oriented programming in our minds, we can start to begin to introduce the ideas behind the solid design principles and then begin to introduce the methods in which we can refactor existing code to follow those types of patterns and what they will ultimately buy for us.